Now, just like this Kirchhoff's current law, which is a general property of currents, we have a general property of voltages around a loop, and that is given by Kirchhoff's voltage law. And what it says is that, let's say we take a loop of elements, okay, and each element has a certain voltage across it, and let me call this V1, V2, V3 and V4. So, you start from a particular node and trace your way around the loop, okay, and you look at the total voltage rise or voltage fall. You look at any one of them. This is analogous to either looking at currents entering the node or currents leaving the node. So, let us say you look at the voltage fall as you go down this path, okay. So, when you go from, let me call this node N1 to node N2, the voltage falls by V2, okay, because N1 is higher than N2 by V2. So, that means that when you go from N1 to N2, the voltage falls by V2. Similarly, when you go from N2 to N3, voltage falls by another V3, and when you go from N3 to N4, the voltage falls by another V4, and finally, when you go from N4 to N1, the voltage falls by minus V1. You can see that N1 is above N4. So, when you go from N4 to N1, the voltage rises by V1, which is the same as saying the voltage falls by minus V1. This is the reason I emphasized earlier that you can think of N1 as being above N4 by V1 or below N4 by minus V1. Okay. So, you will not need to be comfortable with these conventions in order to apply the rules correctly. So, what Kirchhoff's voltage law says is that this is equal to 0. Okay. That is, you go around the loop and sum all the voltages in a consistent direction. You take either rise or fall, the sum will be equal to 0. Of course, you start from a node and come back to the same node. That's when you would have traced the loop once. And just like you can take a rise, you can also equally well take a fall. Okay. But whichever you take, you just do it consistently so that your calculations are correct. Okay. This is Kirchhoff's voltage law. So, what does this mean? Why is this useful? So, let us say you know that, let me take the same circuit again. So, this V1 is 1 volt, V2 is 3 volts, V3 is unknown, and V4 is 5 volts. What does it mean? This is equal to 0. So, that means that 3 volts plus V3 plus 5 volts, which is V4, minus 1 volt, which is V1, equal to 0, and this tells you that V3 is minus 7 volts. Okay. So, you can calculate an unknown voltage. Now, what are the conditions under which this Kirchhoff's voltage law is true? This assumes that there is no significant time varying magnetic field cutting the loop. Okay. You know that if a time varying magnetic field cuts a loop, it induces a voltage in the loop. Okay. In that case, the sum of voltages as you go around the loop is not necessarily 0. Okay. Now we exclude such cases. Again, if our circuits are very small compared to some dimensions which I will leave unspecified for now, this is true. And this is actually a useful thing which is true for a large number of circuits. Okay, it's not that this is applicable only in some narrow useless context. It is actually applicable in a lot of useful contexts as well. So that's why we use that. Okay. You can also make an analogy for Kirchhoff's voltage law based on everyday experience. That is, let's say you start from a certain point and you go up on top of a building, you gain a certain height h2 minus h1, maybe you will come down to a shorter building and you will gain a height of h3 minus h2. Okay, h3 minus h2 is actually negative, and then maybe you will walk down to some underground place. Okay, so I will have h4 minus h3, and finally you come back to where you started off with. Okay, you will gain a height of h1 minus h4. So obviously, if you sum these gain in heights, which are basically stand-ins for gain in potentials, if I multiply this by G, okay, I will have potential gain from 1 to 2, 2 to 3, 3 to 4 and 4 to 1. If you sum up all of these things, obviously you will end up with 0. And Kirchhoff's voltage law is directly analogous to this. And the actual potential arise in any part could be either positive or negative. From 1 to 2 it's of one sign, from 2 to 3 it's of the opposite sign, and so on. But the sum of all of those things taken in a consistent way is 0. Here I have taken the height that is gained. Okay. So that means that uh, this is positive and that is negative. But you could also take it with the opposite polarity and you will end up with exactly the same result. Okay.